Usually my presentations are different. This is why organizer either put me as a keynote speaker or the last one. So being the last one, I appreciate you all coming here. Thank you very much. Before we start to talk about this, I will tell you several things. First of all, at the end of this presentation, I would like you all to understand that Innosia, a French company which I'm consulting recently, has developed something which is a little bit new and different idea of improving the utilization and efficiency of the geothermal power plant with the technologies they have, but also with the understanding of the concept of the whole solution. And talking about understanding the whole solution, I will try to summarize a full day seminar I'm giving to students into 2 or 3 slides. I would like to start with explaining to you what is going on in the markets that we are in, which is the electrical market. Because if we don't have the wide scope, it's very easy to it's very hard to focus on where we can benefit. So we are right now in the middle of a revolution of the electrical market, or the energy market generally. We used to have the old traditional grid with huge power plant pushing everything into the consumer one way, and it is gone. The introduction of the renewable energy, the diversification of the production, the liberalization of the markets are changing the way we are doing business. Today, and especially tomorrow, what the market is going through is a concept of microgrid and energy community. You will hear more and more talks about energy community, about a group of people with common denominator of energy production, energy consuming, and how we can help them to make sure that we are keeping diversity, efficiency, and resilience to our customers. You'll see this in a moment. The smart grid collects different kind of production and take in consideration the other side, which can also contribute to that. It's not anymore one way. It are both ways, and very interestingly, more and more the electrical car becoming a player there as a storage source. Think of it, it's again very wide version of it. I would like to pay attention for you for 2 things. First of all, we are trying to eliminate on the old school of the fossil fuel. Nuclear is here, kept and living, but not the old huge nuclear facilities, but we're talking about a small nuclear reactor, what we call generation type 5 and type 6. It is here. You will meet it more and more because this, plus the geothermal small modular ORC, are going to be the pillar of this new smart grid. They're going to be the base load, because all the rest of them are not base load, and you need to equalize and stabilize the network. Okay? So, geothermal is a true base load and can replace or enhance wherever is applicable. Unfortunately, you can do a geothermal power plant only where there is geothermal. Yes, we all talk about AGS and EGS, and definitely it's going to be valid solution sometime in the future when it will be also commercially available. We are getting closer and closer to that, but we are not there yet today. Of course, the uncertainty is until the first production well. There are a lot of talk about this. I will not stay too long about this. So we don't have too much time. Except for rare case, ORC is the technology for geothermal. You will not find today a real flash system, definitely not double flash system, utilized in the geothermal area. Okay, in New Zealand, which was the biggest area of double flash, you don't find it anymore. They're going for ORCs, some of them big ORCs like Ormat in Tamariki and others like that. Iceland is one of the only places where you can really find a good steam that can operate a big geothermal power plant in a reasonable economical structure. So what we're talking about today is about an energy community. We're talking about efficiency, diversification, and resilience. And we are talking about how geothermal is popular to support this kind of structure, which is the future structure of the electrical market. When we are drilling and when we are investing in well, the highest cost investment and the highest risk, what we would like is to have efficiency. We would like to have as much as possible for what Mother Earth gives us. And according to the depth and the temperature, we are going to have a lot of applications. It's not only electricity, and it is wrong to think that if we have geothermal, what we should do is electricity. No, what we should do is make an efficient combination solution to what we are doing. Okay, I'm just putting here as a star the MED, the MED desalination process, which can be very easily supported by geothermal for island cases where they need fresh water, agriculture, or potable. Okay, this is a very interesting solution. I'm pushing this for quite a while with the Greek islands, which I have a real problem. But I don't know, I guess in Taiwan you have enough fresh water, you don't have this issue, but it's also one of the applications for the geothermal. Okay, so when we are developing a geothermal place, a geothermal resource, we would like to prefer a multi-application solution. We would like to maximize the efficiency of that. We like to involve and support the local communities. It is crucial, again, to think of the big picture. You are coming and you are drilling and you are building a power plant. It's not anymore a huge power plant somewhere where the government says, forget everything, this is the land for us and so on. No, those are small power plants that are next to the communities that they use them. And you find a lot of rejection because it was not explained, it is not educated, it is not brought properly to the communities, they don't understand the benefit. And part of the efforts that companies like Enosia, like Turboden, like Ormat are taking in consideration. I know for sure, I mean, I less know about Turboden, but I know Ormat for 20 years I was working there. I know Enosia as a consultant. Community must be taken in consideration when you are developing a geothermal power plant. You have to maintain the resource control. If you are not maintaining your resource, your geothermal power plant will, or geothermal project will not work properly, and you have to minimize the environmental disturbance. All right? So, we also know each well is different. Therefore, each well has to be considered for the multi-application, for the efficiency, a little bit differently. And you need the knowledge and the expertise to do that. And every well most likely can provide the multi-application. So you can do this. But in order to do this, it must be agreed and designed before. If you do not know this, if you don't take this in consideration when you are building a geothermal power plant, you might find yourself afterwards with something that is not going to be exactly what is needed. Not what the customer wanted, but what the customer needed. There is a difference between the two. Very briefly, what you can expect on the project execution as far as time and more or less average cost in every phase of it. What I want to say in this slide is developing a geothermal power project is a multidiscipline, quite expensive until it is working. Once it is working, it's a honey bunny. As one of my Turkish customers used to say, I'm sitting with my legs out and just rolling the dollars like that. Once it is running. So if it is properly designed ahead of time, it is properly executed, this is the best solution that you can get. This presentation will be available afterwards to everybody, so you can read more of that. So what have we developed in Enosia to suit the needs or the black holes that we found together on the geothermal market? Okay, and in a moment I will tell you why the Enosia solution suits them. But we found two areas where you can quite easily do more with what you have or what you are about to have. One is what we call topping. In many cases, you have existing wells serving existing applications where the temperature is above what you need. District heating, you need about between 75 to 95 degrees to support the district heating. wells. I've seen in Iceland wells that are 125 degrees. For the district heating, they are cooling. They have a pool to cool the brine from 125 to 95 or 90 or 85, whatever they need, to suit the needs of the district heating. Guys, you just wasted 5 megawatt of electricity here. You know? This is something that exists, and it's very easy. It's a very smooth plug-in into existing geothermal systems. You just put there a unit on top of the well, take what it is, and instead of them just cooling it, make electricity out of it. True for the onsens that we've seen all over Japan, you know, and spa facilities. Again, Ormat has a beautiful solution like this in Austria, in Bad Blumau, where you have a well that is supporting about 200 kilowatt of electricity to the hotel, from their district heating, from there to the spa. This is the best efficient solution I've seen in the world until now. We are offering something like that, very easy to implement, and of course immediately join the multi-application. Why also it's important, I'm not sure about here, but at least in the EU, sites that have multi-application gain incentive from the European Commission. So in October 22, the European Commission changed the regulation over there, and you can get incentives for being efficient. It's also important, money is also important. The second solution that we found amazingly suitable for the Enogia solution and a whole in the geothermal project is what we call a single wellhead solution. There are cases where you have already a well which either doesn't provide to you what you are expecting from the total field, or it's the only wells you can drill there. If you drill another well, they are dry, or that this well has been drilled and now it's going to take you another 3 years until you finish drilling all the other wells in order to support a bigger unit. And what do you do with this well? Well, you invested a lot of money there. You can generate electricity meanwhile or together with, and those cases are very clear. We have also cases in oil and gas where gas wells are there and you are extracting hot water with gas and you are wasting the hot water over there. It's another solution for a single wellhead solution. That means you're taking a well and you're just putting one unit on top of the wellhead. You are saving a lot of gathering system cost, okay? And you are starting to produce electricity much faster, or even if it was not even considered before, on something that you already invested. Okay? So today, when introducing Enogia into the geothermal field, we are coming with two concepts, which has to be examined case by case, like you have to do always with a geothermal project, for either a topping solution or a single wellhead solution. All right? Now I'm focusing more into why Enogia. And this is where I'm starting my sales pitch. Till now it was marketing. It was like me being a teacher or lecturer in the university, what I do recently. For me, the best RC solution that exists in the market, I'm sorry, door number 3, okay? Are the large one. If you're talking about a large RC solution, it is Ormat. And we know Ormat has excellent solutions, let's say 10 megawatt and above. And if you talk about small ones, is the Enogia. This is an example of Enogia 1 megawatt, containerized and very easily implemented in the field. Okay? So, again, looking at each project by itself and the project phase, personally, I think you should go to either one of them. But that's my opinion. You may have a different. What is the technology to match the application needs of Enogia? Okay? This is some samples. This is one of the more interesting ones that I've seen from them. And again, when I retired from Ormat after 20 years over there, and they asked me to consult them, and I saw it for the first time, I felt like, wow, this is what the part that was needed to complete the picture. We're talking about a closed, capsulated, patented turbine and generator. We're talking about a It's a very small turbine, high speed, capsulated in something like that size, okay? With the generator inside, with the motor fluid inside, nothing comes in and out except the heat coming in with and the electricity coming out from the generator. All this is containerized with heat exchanger, with a pump, and with a little bit of electrical control, of course. It has a modular approach. You can put many units one next to the other. You have several sizes. We'll see it in a moment. It's a very small footprint. Nothing is coming out of it. It's excellent to implement in area where you have nature reserve or much more environmental concerns. It is very fast in implementation because it's all containerized, capsulated, containerized at the manufacturing site, delivered to the site. If all the civil works are ready, if all the connections for the resource are ready, you're talking about a few days of implementation and start to operate. And Innogia solution can start generate electricity at a temperature of 75 degrees. And this is what was mentioned before when Sam was here in the morning and says, what would you do with wells that are 100 degrees, 110 degrees, which, you know, those of you who have seen this in the morning, what will we do with them? You will generate electricity with them. And you will design the solutions that it will give you district heating at 75 degrees or at 80 degrees, but you still generate electricity from them. You have a solution for a lower temperature, an economical solution, a valid solution, and a proven solution, because Innogia has more than 200 sites over 30 countries around the world, not all of them, very few in geothermal, most of them in other areas, but this is where you have it. And this is the center of one of the solutions, this is another one of the solutions, another one just to see. I'll briefly go over that again, you will be able to see that. What are the key values? The company numbers. It's a small company. It's been recently published, became public on the French stock exchange. It will be a big one, believe me. But today it's a small one. This is the current range of solutions they have. Biggest one is a single unit, 200 kilowatt. But in a recent application that they are doing in South Korea, we're talking about a 10 megawatt unit. That means 25 units on a fuel cell solution, which is distributed along the same area but in several places. Another solution, part of the concept of being independent, each one of them. This is the turbine and the generator. There's a picture just to show you what is the size of the. This is the size of my hand. So this is more or less the size of the unit, just so you can understand what we're talking about. It's different. You didn't see such a thing before. Currently, three approaches to the supply to the market. You can either get only the ORC with the skid, you can get it with the dry cooler, or you can get it all containerized. The reason for these three stages is because in many cases, if you do it locally, it will be cheaper. Okay, so definitely you will not do this locally, but if you want to do other parts of it locally, it will be cheaper. And this is by thinking of the end user at the end of this. Where we are today, what are the references that we see, different sites. Again, you'll see. In geothermal specifically, you can see some of the solutions here. In this case, the air cooler is part of the container. And to summarize in a nutshell, to help you remember, and we have also a one-pager over there, you can go and look at it. We are talking about increasing the utilization and the efficiency of projects of geothermal by either doing a topping solution or a single wellhead solution. Remember those phrases because they will be part of your future vocabulary. Topping means taking the high level of the temperature of what is already existing, plugging in there the generator or a single wellhead. Okay, who is up? She told me time is up. All right, thank you very much.